Okay, like I mentioned just now, there's a more commonly used units, okay, that's called R-ton. So just now, what we have calculated so far, right, your Q evap, okay, your Q condenser, all these are in terms of kilowatts. Okay, so if you want to convert these kilowatts into RT, okay, R-ton, what you need to do is to divide by 3.517, then you will get your load in terms of RT. And for efficiency wise, okay, usually we use COP, okay, but for chiller, okay, usually there's another kind of measurement. We call it kilowatt per ton, okay, kilowatt per ton. So it's actually related to your COP. Okay, so what is this kilowatt per ton? It means, right, how much power you need to provide 1 ton of cooling. Okay, so you can actually interpret this as input, okay, over output. So this is your power input, which is W in, okay, over your amount of cooling you provide, which is Q evap. But your Q evap is not in terms of kilowatts, but it's in terms of RT. Okay, so that's the relationship between these three. So if you use to represent a formula, okay, on how to calculate this, okay, remember we used to learn distance is equal to speed multiplied by time. Okay, so similarly, in this case, these three terms that we have over here is load in terms of ton, okay, power input in terms of kilowatts, and you have your efficiency, okay, in terms of kilowatt per ton. So how are we going to put these three terms inside? Your power, okay, power is equal to load multiplied by efficiency. Okay, or you can say efficiency is equal to power divided by load. But take notes of the units. Okay, the load is in terms of RT, not kilowatts. Okay, so there's this so-called indicator. Okay, how much kilowatt per ton is actually considered good. So usually if your chiller plant efficiency is around 0.7 and below, is considered very good. Okay, but if it's above 1, that means it's very, very poor efficiency and it's time to go and replace your chillers. So with reference to the answers we get, okay, in example 2.1 and 2.2.3, what is the cooling load of the chiller in tonnage? And what is the efficiency in kilowatt per ton? Okay, so previously in our example, we got Q evap. Okay, Q evap is equal to 1255. Okay, so they ask what is the load in terms of ton. So what you need to do is equal to 1255 over 3.517. Then you will get your answer in terms of ton. Okay, so that is to say now the cooling load is 357 RT. Okay, and what is the efficiency in kilowatt per ton? So if you use the triangle thing, okay, if you use this, to find efficiency, you will need to use power divided by load. So the power we have calculated just now is 271, okay, 271 kilowatts, divided by the load, which is 357, and you'll get an efficiency of 0.76. So that's how you use the formulas, okay, to calculate efficiency in terms of kilowatt per ton. Okay, or because we have already calculated the COP before, the relationship between COP and kilowatt per ton is actually COP is equal to 3.517 divided by your efficiency in kilowatt per ton. Okay, so if you want to find your efficiency in kilowatt per ton, you can take 3.517 divided by your COP. Okay, it's just switching the places. Okay, so it will look like this. You will get the exact same answer. Okay, that is 0.76 kilowatt per ton. Okay, with that, let's try one example, a so-called a full example, okay, using some schematic shown on your next slide, okay. So there are three things you need to find. You need to find the cooling load for chiller 3 and chiller 4 in kilowatts as well as in tonnage, okay. And you need to find a chiller efficiency in COP as well as kilowatt per ton. Okay, and finally, your plant efficiency with all this power given. Okay, how do you find the plant efficiency? So if you refer to the schematic, okay, you are only going to concentrate on chiller 3 and chiller 4. So all the important information are actually given. You have your supply temperature, return temperature, and the flow rate. That's good enough for you to calculate the load of the chiller. Okay, so what you're going to do, okay, so it'll be very good that if you can list down all the important parameters first before you start your calculation. So you may want to pause the video and try it out yourself first to get familiar with how to use all these formulas. Okay, if not, I will continue with solving this particular question. Okay, so for chiller 3, very simple. Okay, I will just demonstrate. You can find the load by using Q evap is equal to M C delta T. Okay, so your mass flow rate is actually your flow rate in liter per second, 32.7, multiplied by CW, which is specific capacity of water, 4.19, multiplied by delta T. Delta T is the temperature difference between your return and supply. So it will be 12.7 minus 6.4. So you just need to compute this out. You will get your answer in terms of kilowatts. Okay. And you need to divide by 3.517 to get your answer in terms of RT. Okay. So that is for chiller 3. So repeat this process for chiller 4 just by changing all the numbers here. Instead of 32.7, you will use 31.9. Okay, and the temperature will be 13.1 minus 9 degrees Celsius. Then you will get your load. Okay. So first you will get 863 kilowatts and 245 RT. Okay. And similarly, for your chiller 4, you'll get 548 kilowatts and 156 R-ton. Okay. And to get your efficiency, remember to get your efficiency, if you want to find COP, what you do is you take Q evap, okay, over power input. So Q evap, let's say I'm talking about chiller 3, Q evap is 863, and power input from your chiller panel is 150. Okay, that's where you get your COP. But if you want to get your efficiency in kilowatt per ton, you will take power input, divide by Q evap in terms of RT. Okay, Q evap in terms of RT. So you will take 150, divide by, not 863, but instead you will divide by 245. Then you will get your answer in kilowatt per ton. Okay, so that is the method that you are going to use. Okay, so I think for part A, they actually ask for the total building load in tonnage. So what you're going to do is you add 245, okay, 245 RT with 156, that's your building load. Okay, so what I've shown you just now is actually for your part B. You take 863, divide by 150, you get 5.75, okay, or you can take 150, divide by 245, you get 0.61, okay. Then for chiller 4, using the same method, just that you sub in different readings, okay, you will get another set of efficiency. So from here, you can tell that chiller 4 is actually less efficient compared to chiller 3. Why is that so? Because chiller 3 has a lower kilowatt per ton. Okay, so it's different from COP. For COP, right, the higher the value, the more efficient it is. But for kilowatt per ton, okay, for kilowatt per ton, the lower the value, the better it is. Okay, because it is input over output. So the lower it is, it means you require less input to get the same amount of output. Okay, so kilowatt per ton is the smaller, the better. So in this case, chiller 3 will be better. Okay, finally, for part C, very simple, you want to calculate the plant efficiency. Okay, that means you consider everything. So remember, for water side, we have the chilled water pumps, we have the condenser water pumps, we have the cooling towers. So you have to take into account these three components. Okay, what is the power consumption together with your chillers, okay, and divide by your building load. Okay, so from part A, we know that our building load is 401. Correct? So you need to take all the power consumption at the water side, divide by 401. You will get the kilowatt per ton for the whole plant. Okay, so how do you do that? Okay, you sum up all the power consumption. 150 plus 106 because your chiller 1 and chiller 3 and chiller 4 and the pumps and cooling towers, you will get 308 kilowatts. Divide by the building load, you'll get 0.77 kilowatt per ton. Okay, so that's the calculation. One thing to take note, when you are calculating for plant efficiency, never ever go and add the air side equipment. Okay, that means you don't go and include the power consumption of your AHU, the power consumption of your FCU, and things like that. You only consider the water side power consumption, divide by the building load. Okay, so that's how they compare this value. Okay, in the industry, they don't include the air side equipment.